In mathematics, identities are the equations which are satisfied for any values of the involved variables. Identities help us to solve some mathematical problems easily. Similarly, in trigonometry, we have identities that help us to solve trigonometric problems. Tan theta is equal to sine theta over cos theta for any value of angle theta. For example, tan 30 degrees is equal to sine 30 degrees over cos 30 degrees. Tan 45 degrees is equal to sine 45 degrees over cos 45 degrees. And tan 60 degrees is equal to sine 60 degrees over cos 60 degrees. Thus, it's an identity. Similarly, cot theta is equal to cos theta over sine theta is also an identity, as it is satisfied for any value of angle theta. For example, cot 30 degrees is equal to cos 30 degrees over sine 30 degrees. Cot 45 degrees is equal to cos 45 degrees over sine 45 degrees. And cot 60 degrees is equal to cos 60 degrees over sine 60 degrees. What can you say about the product of the cosecant and sine of an angle? We know that the sine and cosecant are reciprocals. Therefore, the product of sine and cosecant of an angle is equal to 1 for any value of angle theta, provided sine theta is not equal to 0. What can you say about the product of secant and cosine of an angle? Cosine and secant are reciprocals as well. So, the product of cosine and secant of an angle is equal to 1 for any value of angle theta, provided cos theta is not equal to 0. What about the product of tangent and cotangent of an angle? Again, tangent and cotangent are reciprocals. Therefore, the product of tangent and cotangent is equal to 1 for any value of angle theta, provided tan theta and cot theta are not equal to 0. All these are identities, as they are satisfied for any value of angle theta, for which the involved trigonometric functions are defined. In trigonometry, there are some more identities called fundamental identities. The fundamental identities in trigonometry are derived by using Pythagoras' theorem. Consider a right-angled triangle ABC. By Pythagoras' theorem, we can write AB squared plus BC squared is equal to AC squared. Divide each term by AC squared. What can you say about AB over AC and BC over AC? From triangle ABC, cos theta is equal to AB over AC and sine theta is equal to BC over AC. Thus, we get cos squared theta plus sine squared theta is equal to 1. Cos squared theta plus sine squared theta equal to 1 is a fundamental trigonometric identity. Let's verify it by using the values of sine and cos for some specific angles. Let's start with 0 degrees. The value of sine squared 0 plus cos squared 0 is equal to 1. The value of cos squared 30 plus sine squared 30 is equal to 1. Similarly, cos squared 45 plus sine squared 45 is equal to 1. And cos squared 60 plus sine squared 60 is equal to 1. So the identity cos squared theta plus sin squared theta equal to 1 is true for any angle. Let's go back to the right-angle triangle ABC. Applying Pythagoras' theorem, we can write AB squared plus BC squared is equal to AC squared. Now, divide each term by AB squared. What can you say about BC over AB and AC over AB? From the triangle ABC, tan theta is equal to BC over AB, and secant theta is equal to AC over AB. Thus, we get 1 plus tan squared theta is equal to secant squared theta. Therefore, secant squared theta minus tan squared theta is equal to 1. Let's verify this identity using the values of tan and secant for some angles. Starting with 0 degrees, we can see that secant squared 0 minus tan squared 0 is equal to 1. Similarly, secant squared 30 minus tan squared 30 is equal to 1. And secant squared 45 minus tan squared 45 is equal to 1. Therefore, the identity is true for any angle for which secant and tangents are defined. Let's see if we can work out another identity using Pythagoras' theorem. Can you guess by what value we should divide? Yes, divide each term by BC squared. What can you say about AB over BC and AC over BC? From the triangle ABC, cot theta is equal to AB over BC and cosecant theta is equal to AC over BC. Thus, we get cot squared theta plus 1 is equal to cosecant squared theta. Therefore, cosecant squared theta minus cot squared theta is equal to 1. Observe the values of cosecant and cotangent in the table. The value of cosecant squared 30 minus cot squared 30 is equal to 1. And cosecant squared 45 minus cot squared 45 is equal to 1. Therefore, the identity is true for any angle for which cosecant theta and cot theta are defined. Are you wondering how you're going to remember so many identities? Relax. Most of the identities are basic. We call them as reciprocal and ratio